Okay, students, now we are going to discuss another question, that is here. Please read this question. A balloon contains helium at 53 degrees centigrade and bursts suddenly. The expansion of helium is. So here a balloon contains helium at 53 degrees centigrade and 1 atmosphere. Bursts suddenly. The expansion of helium is. Here the very important point is bursts suddenly, sudden expansion. So this expansion is nothing but adiabatic expansion. Okay, adiabatic expansion is irreversible adiabatic expansion. Irreversible adiabatic expansion. Why? Because that process not reversible. It is irreversible adiabatic expansion. Okay. So this is a balloon. This balloon contains helium at 53 degrees centigrade and 1 atmosphere. So our answer is sudden expansion is nothing but adiabatic. This is irreversible adiabatic expansion. Okay, another question. A triatomic molecule in the shape of a triangle can be assumed that atoms are at vertical vertices of the triangle and joined by massless rods. Internal energy of 1 mole of temperature T is. This is a triatomic gas. Now we want to find out internal energy. See, this triatomic molecule is a non-linear molecule. Non-linear molecule, so that it has 6 degrees of freedom. How many degrees of freedom here? 6 degrees of freedom. So if the temperature is increased, then it has 1 degree of freedom also, that is vibrational degrees of freedom. But here temperature is not such amount is increased. At normal temperature it has only 6 degrees of freedom. So internal energy of 1 mole of this triatomic gas is U is equal to, we know that F by 2 nRT. F by 2 nRT. Okay. Here they gave N is equal to 1 mole and F is equal to 6. U is equal to 6 by 2 into 1 into RT. U is equal to what we write here? Here this is 3 RT. 3 RT. So our answer is U is equal to 3 RT. This is the correct answer. Okay, now we are going to discuss another problem. Pressure inside 2 soap bubbles is 1.01 atmosphere and 1.02 atmosphere. Find the ratio of their volumes. Right. So these are the 2 soap bubbles. So we know that bubbles are in the shape of spherical shape. They have spherical shape. This is first bubble and this is second bubble. So inside the first bubble there is a pressure 1.01 atmosphere. Inside the second bubble there is a pressure 1.02 atmosphere. What is the pressure outside the first bubble? 1 atmosphere pressure. This is also 1 atmosphere pressure. So excess pressure inside the first bubble is equal to 1.01 minus 1, that is equal to 0.01 atmosphere. Excess pressure inside the second bubble, P2 is equal to 1.02 minus 1, that is equal to 0.02 atmosphere. Okay. So we know that excess pressure inside the bubble is equal to 4T by R. P inversely proportional to 1 by R. P inversely proportional to 1 by R. That means R1 by R2 is equal to P2 by P1. P2 by P1. Right. So here volume of the bubble is equal to 4 by 3 pi R cube. That means V is directly proportional to R cube. V is directly proportional to R cube. Right. That means V1 by V2 is equal to R1 cube by R2 cube. Okay. R1 cube by R2 cube. So that means V1 by V2 is equal to R1 by R2 P2 by P1 whole cube. So V1 by V2 is equal to P2 0.02 divided by 0.01 whole cube. That is equal to 8 by 1. So V1 is to V2 is equal to 8 is to 1. This is the correct answer. Okay, let us discuss another question. In this question, a diode has potential drop of 0.5 volts in forward bias. The maximum current that can flow through the diode is 10 milliamperes. Then find the resistance connected in series with the diode so that the setup can be converted to a battery of 1.5 volts. Right. So this diode is connected in forward bias. This is a diode. This diode is connected to a battery in forward bias. Of voltage 1.5 volts. Of voltage how much? 1.5 volts. Right. With a series resistance R. So here in this problem, how much potential drop across diode? 0.5 volts. 0.5 volts. Right. So remaining the potential drop across resistance is nothing but 1 volt. 1 volt. What is the maximum current that can flow through the diode? Maximum current that can flow through the diode is I is equal to 10 milliamperes. 10 milliamperes. So we know that how much resistance is to be connected to the diode in series. We want to find out that. So V is equal to potential drop across the diode, V equal to I into R. V means how much voltage? 1 volt is equal to I 10 into 10 to the power of minus 3 amperes to R. So here 1 is equal to 10 to the power of minus 2 into R. So R is equal to 1 by 10 to the power of minus 2, that is equal to 10 square, that is equal to 100 ohms. So we should connect 100 ohm resistance across 100 ohm resistance in series to the diode.